Hello to all the computer science students, class 11. Okay, this is your Sir Alam. Okay, your computer science teacher. Once again, greeting you. So welcome to Saint John Higher Secondary School. So your classes, online classes, starts from 1st July. So after this introductory video, okay, I'll start your first videos. Okay, online video. So it will be uploaded in YouTube. Okay, so I've created a folder there for I named it class 11 computer science. Okay, so when you go to the Google Classroom, okay, and you click on the YouTube link, okay, so all my videos will be uploaded there and you can watch and learn from there. Okay, so sometimes I may upload my own videos, sometimes I may upload tutorials, okay, some links from YouTube. So because like there are some pictorial diagrams or say like 3D diagrams, okay, which uh, can be understood better with means if you visually see it. Okay, so for such kind of explanation, I'll be uploading video tutorial links. Okay, and then sometimes I'll be giving you assignments also. So assignments, you need to do it very sincerely, diligently. Okay, you should submit on proper time, and then like because it will carry marks. So you just recently got promoted from your high school, okay, and now you are entered higher secondary, so you are now at a higher learning stage. Okay, similarly, regarding this subject, computer science, so those of you who are taking computer science, okay, uh, some of you might have in the high school, you might have taken IIT, FIT, right? So if you have bought the textbook, for those of students who have bought the textbook, if you see the contents, you'll see that the contents, especially the first unit, it's much similar to what you have learned in your high school days, like regarding the hardware, software, introduction to computers, like the right operating system. So all these things are basically what you have learned in your high school. So you'll be familiar with that, and you won't find that much problem going through those chapters. So that is what I'll be starting first. Okay, so for those students who have not done FIT or taken FIT or IIT subject, okay, still then I'm sure that every one of you must have used computer at least once in your lifetime, right? So you have all seen computers, you have your own mobile handset, so that is also a computer. Okay, so to say that you do not know what is a computer, okay, right, at this age of technology, okay, that is absurd. So I'm sure that all of you know at least the basics of the computer. Okay, so uh, regarding the syllabus, okay, so like I said, if you're taking this subject, be very sincere. Okay, because what you have learned in high school and what you're going to learn now, okay, except for the first unit, the rest of the unit is different. It's completely different. Okay, so only if you learn very nicely in class 11 the basics, okay, then when you reach class 12, okay, then uh, it's a continuation of this textbook only, so only then you will understand very nicely. Okay, so and computer is this programming, you will be learning programming language, so it's all about concepts, logics. Okay, so your reasoning has to be good, so that's why it's like a little bit like maths. Okay, but again it's different. Okay, so as we go through chapter wise, you will understand the difference of this subject from your high school's textbook. Okay, now those of you who have your textbook, okay, uh, you can refer from the textbook. Okay, so if you see the textbook, this textbook has been divided into 4 units. Okay, 4 units. The first unit is called computer fundamentals. Okay, and as you can see in the chart distribution, okay, the marks is written as 10. Okay, then second unit is introduction to C++, so that is programming language. Okay, and that is 14 marks. It carries 14 marks. Third unit is programming methodology, and that carries 12 marks. And the last unit is programming in C++, that is the continuation of the second unit, that is introduction to C++. Okay, so that carries 34 marks. So altogether you have the total is 70. Okay, so 70 is your theory questions. Okay, and 30 marks is practical. Okay, so regarding the practical, I don't know whether we will have practical or not, but still then that is that carries, that will be, I consider will be as internal marks. So 30 marks will be your practical marks, or it may be your internal marks. Okay, so and 70 marks is theory based. So uh, out of 70, okay, the pass mark is 21. Okay, so the pass mark is 21. So the subject itself is actually quite easy to pass. Actually, you can easily get pass mark, but pass mark is not the only thing that is what you're taking the subject for, right? If you're taking the subject, you should never be satisfied with the pass mark. You should be satisfied with higher marks, right? So I hope that all of the students who are taking these subjects are very diligent, sincere students, okay, and that you will score good marks. Okay, so now coming back to the syllabus. Okay, so it carries 70 marks, and as you can see the mark distribution, if you add up all the marks, okay, 10, 14, 12, 34, it comes exactly 70. Okay, so when the question paper is set up also, okay, when the board sets the question paper also, it will set the marks according to this unit wise. So unit wise, if it is written there 10 marks, it will come exactly 10 marks. Okay, so it may be that one unit may have one chapter, or maybe have two chapters, or sometimes it may have 6 chapters. Okay, so depending on the unit, different chapters are there. Okay, you have more than, I think, 15 chapters or 16 chapters like that. So all those chapters is comprised of the 4 units, and that all those chapters carries total 70 marks. So every chapter is equally important. You cannot just skip one chapter and then study another chapter. If you're studying a particular unit, you need to study all the chapters, because if suppose one unit has 4 chapters and you study only 3 chapters and you skip one chapter, right? Now that chapter, from that chapter, marks may come, and then if you miss out on that, you lose precious marks. Okay, so like I said, unit wise, okay, mark distribution is given, and it is very important that you study on that basis. Okay, so 30 marks is your practical marks. Okay, so uh, it will be your internal marks. Now if you see the like I said, if you see the first unit comprises of the basics of computer only. Okay, the first unit is comprised of the basics of computer, and then in the second unit, okay, you'll be learning new things. So means like the programming languages. Okay, the programming languages. Third unit is how you create what are the steps to create a program. Okay, I think you have already learned about the definitions of programs, or like softwares, application software, system softwares in your high school classes, right? Okay, so all of those things what you have learned will also help you understand the basics about this chapter, this subject. Okay, so if you go to the unit 1, you will see that it is divided into 6 chapters. Okay, 6 chapters. So those of you who have your textbook, okay, you can refer from the textbook. Okay, for those students who have still not got the textbook, okay, um, try to understand try to catch up with what I'm saying, okay? And if you have any problem understanding, okay, I can take screenshots of the pages, okay, and then send it to you also. So today I'll just cover the first chapter, that is from unit 1, the first chapter, that is evolution of computer. Okay, now the unit 1 is actually quite very simple, totally basic. Okay, talks about the origin of computers, what is computers, types of computers, like that. And I think most of you know, already know this. Okay, so now it's already July, we are in 1st of July, right? So we only have a very few months left, around 6-7 months left, right? So within this time, all of these chapters, 15-16 chapters, has to be finished. Okay, so regarding the first unit, okay, I'll go like on a fast track basis. So since most of you I think can understand that, okay, so programming part, the second unit, the third unit, the fourth unit is actually more important, because that will be taught in your class 12 also. Okay, so the first unit, okay, I'll focus on the important ones. Okay, the rest I think you can also understand from the textbook. Okay, so the first part is the evolution of computers. Okay, it's just some few pages. Okay, so this can be wind up very soon also. Now another thing that you will observe is, before I start, okay, if you go to the last pages, in every end of the chapters, right, there is the points to remember. Okay, and on the left hand side and on the right hand side of every page, there is that section called as note, right? Now those are also important, and the points to remember are also important. Okay, from points to remember also, like 1 mark, 2 marks questions also used to come. Okay, and points to remember is something like a summary. Okay, so which sums up all the topics that you have learned. Okay, so it all the important topics that you have learned, so refer to that points to remember, study on that points to remember, try to understand from there. Okay, and then solve exercises. Okay, solve exercises is very important. The questions, the long answers, the short answers that is given in the solve exercises, okay, you should not neglect at all. Okay, and then the review questions. Okay, the review questions is also like it is from the textbook. Okay, so you should refer to that from the review questions also. Okay, so like I said, study the points to you should always study the points to remember. Okay, the note that is given on the left and right hand side. Okay, and then the solve exercises and also the review questions. Okay, and not only that, but yes, you have to go through the textbook also. Okay, so coming back to the first chapter, that is evolution of computers, chapter 1. Okay, first unit. If you have your textbook, okay, you can flip onto the first page, that is page number 1.3. Okay, now in the beginning of every chapter you will have the contents, right? So it's given there, this chapter contains introduction, characteristics of computer, functional components, so and so, like that. Okay, so we'll be seeing all this topic one at a time. Okay, so in the first part, introduction, yes, sometimes I'll go through the paragraph. Okay, and then you can also go through the paragraph. Okay, and then I will explain that, I'll elaborate on that topic. Okay, so to be an educated citizen today, you must have a general understanding of computer capabilities and limitation. The word computer may be used for any device that may be employed to compute or to calculate. Okay, so what is a computer? The definition is given there. Okay, now but think about the word computer. Okay, computer. So from where did that word came? Okay, the did came from the Latin word compute. Okay, that means, it means to calculate. Okay, so computer, the word computer itself means to calculate. Okay, so that sentence, the word computer may be used for any device that may be employed to compute or to calculate. Okay, so what was the first purpose of why a computer was created? It was meant created for to calculate. Okay, meaning the creation of computer. Why was the necessity of the computer to be created? Okay, it was to calculate, to compute, to do calculation. Okay, just like your calculator, right? Okay, so the first origin of the computer was, the main purpose was for that. Okay, so the word stuck to that. Now, such a device operates on data numbers to respond them into a more useful form in contemporary usage. Being a machine, a computer will not perform independently or creatively. Okay, yes, so it does not perform independently or creatively. It it uh, it waits for us, the users, to type something or to input something like that, right? So it cannot work on its own. Okay, it's a machine. Okay, but it has no thinking capability of its own. It cannot work on its own. Okay, you need to switch on, you need to boot it, you need to type something. Okay, and then it will process, and then it will display, right? So it will only do what it is instructed to in specific terms. It is based on complex technology but works on a simple principle. If you can see the diagram below, input, process, output. Okay, three things: input, process, output. That is the whole concept of computer. Okay, input, process, output. The whole logic behind the computer is that only: input, process, output. So if you go back to the definition of computer, okay, what is a computer? If you see that definition, a computer is an electronic device which inputs data, instructions, stores and processes it, and produces output in the desired form. Okay, computer is an electronic device. Okay, it accepts input, processes that input data, okay, and then uh, produces output in desired format. So it is an electronic device. It is not an electrical device. It is not a mechanical device. Okay, earlier computers, yes, it was a mechanical device. Okay, but still then we don't call it an electrical device. When we talk about electrical device, you're talking about a tube light, light bulb, okay, fan, okay, all these are like use electricity, so these are electrical devices, right? But yes, if you talk about your laptop, though it's portable, it needs electricity, right? And it needs to, the battery needs to charge, for that it needs electricity, right? And then if you talk about your desktop computers also, same case, without power supply, okay, it cannot run, right? Then if it needs electricity, then how is it different from an electronic device, right? So there is a difference between an electrical device and an electronic device. Okay, electrical device, okay, AC current, DC current, right? The concept is that. I'm sure that you'll be learning more about that in physics. Okay, but when we talk about electronic device, okay, you're you're talking about in terms of computer language, okay, in terms of digital bits and bytes. Okay, so that is a computer. Okay, so a computer is an electronic device. Okay, so it will accept input data. Now when you talk about this data, okay, data, when you further elaborate what is data, okay, you talk about data as a collection of raw facts and figures. Okay, a collection of raw facts and figures. Okay, now suppose you are a new student. Okay, I don't know anything about you. Okay, you same way, you also don't know anything about me, right? Okay, so let's say, suppose like one of your name is, suppose like say like Toshi, right? So let's say, suppose like in a box, okay, on a piece of paper, I write your name Toshi, okay, and then on another box I write suppose like class 11, okay, and then on another box on a piece of paper I write say like science and then put it there, and then on another box I write suppose like St. John Higher Secondary Residential School, okay, and then so you have four different boxes. On one box there is a name Toshi, on another box it's like class 11, on another box it's like it's written their science stream, okay, and on another box there is St. John School, right? Now if you were to separately collecting that raw data, okay, raw facts and figures, right, okay, raw facts, it's a fact that Toshi is there, it's a fact that St. John School exists, it's a fact that there is a science stream, it's a fact that class 11 is there, right, class 11, class 12, like that, right? So all these are actual facts, okay, but raw, because they are all separate in on separate boxes, right? So what happened is that data is a collection of raw facts and figures in terms of numbers, right? So what happened is that if I collect all those boxes, okay, and then I take out the papers, okay, and then line them up, so what will happen is that it will read suppose like Toshi, okay, class 11, science stream, St. John Higher Secondary Residential School. Now what happened is that from there you get an information about a particular student who is in class 11 and who has studied in St. John Higher Secondary School and belongs to the science stream, right? So you see that the raw facts, the raw data, okay, becomes a collection of information, okay. So that is what a computer does, okay. It uh, the your input data is raw, okay, it processes it. When it processes it and then you get the output, okay, it becomes a useful information, okay, something like 1 plus 1. Now when you press enter equals to 2, you get an information, okay. Raw figures 1 plus 1, you get means like an information too. Now if you have a very difficult number, suppose like a huge number, right, a huge number plus huge number, you don't know, when you press enter and you get equal to, you get the correct data, right? So that is the correct information that you're getting, okay. So that is what a computer does, okay. So the whole concept of a computer is input process output, okay, input process output. When you talk about your mobile phone, when you talk about your tablet, okay, your mobile phone is an electronic device, your tablet is an electronic device, your laptop is an electronic device, okay, but they are all computers. Only thing is that because of their size, okay, because of their size and because of their different uses, okay, uh, it is called by a different name, but all are computers only, because the whole concept is, be it your mobile phone, okay, the concept behind it is input process output, okay. So you cannot call your the computer is not only your desktop computer or your laptop computer, okay, or your netbook or your notebook, okay. It is also your tablet, it is also your mobile phone, okay, it is also your suppose like your a digital watch, okay. So all of these things are computer. Only thing is that based on the size, okay, and the usage of it, it is called by a different name so as to categorize it, okay. So that is what is a computer, okay. I hope that you have understood from that, okay. Now coming back to the characteristics of the computer, okay, I'll go a bit fast on that. Now in the first part you have speed, okay. Now speed is measured in clock cycles, that is hertz, okay. That also I think you will understand much better in physics terms, okay. Now it is measured in terms of nanosecond or millisecond, microsecond, picosecond, like that, okay. So the speed of a computer is usually measured in nanoseconds, okay. Now First, if you see the textbook in the first part, okay, a millisecond is 1,000 of a second. Okay, a millisecond is 1,000 of a second. Now you think about second, 1 second, 2 second. Okay, the time duration between shifting from 1 second to another second, it's like this, 2, 1, 2, like that, right? So if I ask you a question, okay, suppose like add up, right? Suppose like 1 plus 1, right? Now you think a bit and then you answer. But what happened is that you are at least consuming or taking up 1 second or half second, like that, right? Now in terms of a computer, okay, the earlier computers, it was in terms of millisecond. Millisecond is 1/1000 of a second. That means in between a second, the first second and the second, there is at least 1000 gap. Okay, if I have to tell you practically, okay, like in say like in general terms, okay, you just think about this second and this second, the second one, second two, right? 1 second, 2 second, so like a stick, okay, and then in between that, the first second and the second second, okay, there is exactly like 999 sticks planted. So you just imagine that if you are taking 1 second to reply an answer, okay, the computer, okay, is faster than you by 1000 times of a second. Okay, so you are taking 1 second, but the speed is that, okay, the computer is 1/1000 times faster than your reply. Okay, so it means that uh, and the next one is microsecond, which is 1/million. So in terms of computer, it is nanosecond, which is 1 billionth of a second, which means in between 1 second and another second, okay, let's say imagine that there is exactly, okay, 1 billion sticks in between the first second and the second. Okay, so you just imagine the speed of the computers. Okay, before you can even think, it has already got the answer. Okay, so still then, yes, we talk about the speed of the computer, we always go for higher speed, right? But still then, the slow speed of a computer is even much faster than our reply, our answer.